Although the name of the problem is transportation problem, it doesn't always have to be about sending items from supplier to the demand points. In this video, we're going to look at the inventory problem that we may also model as a transportation problem. In this example, Sailco Corporation must determine how many sailboats to be produced during each of the next 4 quarters. So for each of the next 4 quarters, there is the demand that must be met on time. To produce the sailboats, Sailco can produce using regular time with the total cost of $400 per sailboat, but during this regular time, only 40 sailboats may be produced at most. Sailco may produce additional sailboats using the overtime labor, but the cost becomes $450. There's a carrying or holding cost for each item that Sailco keep at the end of a quarter, which is $20 per sailboat. And what we would like to do is to minimize all the costs, both the production cost and inventory cost. There will be a pause on the video to give you the time to read this problem carefully before you continue. To model the inventory problem as a transportation problem, we need to define who are the supply points and who are the demand points. For the demand points, I think it's pretty clear that the demand for each quarter should become the demand point. So we have 4 demand points, and each demand point has the demand according to the demand of that quarter. Now for the supply points, if we think about it, the supply of the sailboats in this example comes from either regular time or overtime in each quarter. So that's why we need to separate quarter 1 regular time, quarter 1 overtime, quarter 2 regular time, quarter 2 overtime, and so on up to quarter 4 regular time and quarter 4 overtime. So how do you know that you need to separate this based on quarters? Well, because if you produce something at, let's say, quarter 1, you can use that production to satisfy the demand at quarter 1, 2, 3, and 4, right? But if you produce something, let's say at quarter 4, then you cannot use that production to fulfill the demand from the previous quarter. You cannot use what you produce at quarter 4 to satisfy the demand at quarter 1, 2, and 3. That's why you need to separate the production from quarter 1 or quarter 2, 3, or 4. Okay, and furthermore, you also need to separate the supply points into either the sailboats are produced from the regular time or the overtime. The reason here is because you see that the capacity is different. For regular time, we can only produce up to 40 sailboats. And then the cost is also different. For regular time, $400 per sailboat. For overtime, $450 per sailboat. So because the cost is different, the capacity, the production capacity is also different. That's why you need to separate them into the supply point for the regular time and the supply point for the overtime. Okay. Now let's talk about why we get the capacity of the overtime equals 150. Well, if you think about it, actually there is one more supply point, and that comes from our initial inventory. In the problem, it says that at the beginning of this problem, we have an initial inventory of 10 sailboats in our warehouse. So that is also another supply point because that's something that we can use to fulfill the demand, right? So we have the supply points comes from the initial inventory and then regular time and overtime for each of the 4 quarters. Okay, so for overtime, let's talk about this number. So if you take the total demand here, the total demand is 200. So how can you fulfill those demand of 200 sailboats? Well, because these 10 items are already available, then it's kind of logical to just use them, right? So we use 10 from the initial inventory, and then let's say we produce 40 from the regular time. Again, it's logical because the cost from regular time is smaller. So it is reasonable that we try to produce as much as possible from the regular time. And then suppose we use the initial inventory and then regular time, and then we want to fulfill the remaining demand using overtime, then you can get this number 150 because the total demand is 200, and then we use the beginning inventory 10 sailboats, so now the remaining demand becomes 190. And then we produce the sailboats from the overtime, 40 sailboats. So now the remaining is only 150. So that is kind of the maximum overtime that we may use if we want to satisfy all the demands. There is, at most, we will use 150 production capacity from the overtime. Why not more than 150? Well, because just from this tree is already enough to satisfy all the demands for all quarters, right? So that's how we get the number 150. So it comes from assuming that we want to satisfy all the remaining demands just with just with one time of doing overtime. Okay. So now, because we say that the capacity of overtime is maximum 150, so it's the same either for quarter 1, 2, 3, and 4. Now we see here that we have more supply than the demand. To make the problem balance, we need to add a dummy point, in this case a dummy demand point, with the capacity of 570. So now the problem becomes a balanced transportation problem. Now let's start by looking at all the costs that may incur for the supply points of the initial inventory. The initial inventory, we have 10 units of sailboats. And then if we use this inventory to satisfy the demand at quarter 1, then we do not incur any cost, right? Because we do not produce this and we do not store this anymore at the end of quarter 1. So there is no cost. However, if the initial inventory that we have right now and then we use it to fulfill the demand at quarter 2, we get the cost of $20. Why? Because we keep this initial inventory in our warehouse at the end of the first month. At the end of the first month to fulfill the demand at quarter 2. Sorry, at the end of the first quarter to fulfill the demand at quarter 2. So we have the holding cost $20 at the end of quarter 1. If we use this beginning inventory to fulfill the demand at quarter 3, it means that we keep these sailboats at the end of quarter 1, at the end of quarter 2. So the cost becomes 2 times 20, which is 40. If we use this initial inventory to fulfill the demand at quarter 4, it means that we keep these sailboats in our warehouse at the end of quarter 1, at the end of quarter 2, at the end of quarter 3 to use it to fulfill the demand at quarter 4. So we keep it for 3 months, sorry, for 3 quarters. So that's why the cost is 60. And then finally for dummy demand point, because it's really dummy and it's just something that does not exist in reality, the cost is 0. Okay. And then if you look at the number here, there is the number 10. Um, it means that in this solution, we use the initial inventory 10 units to fulfill the demand at quarter one. Again, we have not talked about how we can get any solution. So don't be confused how we can get this value 10 right here. At this point, let's just take it just as an example, okay? We have not talked about how we can get that, but this is just an example. Okay, the focus of this slide is how you determine the cost at the small squares for the quarter 1, 2, 3, 4, and the dummy demand points. Now let's take a look at another supply point, which is the regular time from quarter 1. The capacity for regular time is 40 sailboats, so you write down 40 here. Now for the cost, if you produce something at regular time in quarter 1 and you use it to fulfill the demand at quarter 1, then the cost that you pay comes from the production cost only, which is 400 per sailboat. But if you produce something at quarter 1 using regular time, and then you use it to fulfill the demand at quarter 2, it means now the cost is the production cost, $400 per sailboat, plus $20 because you keep that sailboat in the warehouse at the end of quarter 1. So the total becomes 420. Now let's see how this cost here becomes 460. Well, because here it means that you produce something at quarter 1 regular time, but you use it to fulfill the demand at quarter 4. It means that you produce that sailboat with the cost of 400, and then you keep it at the end of the first quarter, second quarter, and third quarter. So you keep it for 3 quarters. That's when the total cost becomes 400 plus 3 times $20. So the total becomes 460. And again, this 460 means the cost for each sailboat that you produce at quarter 1 regular time and you use it to fulfill the demand at quarter 4. For overtime, it's very similar, except now that the production cost becomes 450 per sailboat. So if you produce at quarter 1 overtime and then you use it to fulfill the demand at quarter 1 itself, only the production cost occurs, 450. If you use it to fulfill the demand at quarter 2, now it becomes 450 plus the holding cost of $20 at the end of the first quarter, because you produce in quarter 1, but you use it to fulfill the demand at quarter 2. So you keep it for 1 quarter. Okay, and then the cost for dummy is 0 because the problem does not say if we have more capacity to produce sailboats then there's a cost or anything. No, the problem doesn't say anything about it, so the cost for dummy demand point in this problem equals 0. Now if you look at the second quarter, you see that we have big M here, which means that we cannot produce something in quarter 2 but then use it to fulfill the demand in quarter 1. That is impossible. So for all those impossible things, we put the cost as big M, which is a very big number. Okay. Now, once more, you just ignore these values inside the cell at this moment because we have not talked about how we can get the solution to this problem. So ignore all the values inside the cell. Okay. What I really like you to do is that you really try to try by yourself, convince yourself that you know all these numbers, where they come from. Like this 450, 400, 490, and so on. Convince yourself that you really understand where all those numbers come from. Okay, there will be a pause on the video to give you the time to really work on this example until you convince yourself that you know how to calculate all the costs corresponding to each of this cell from one quarter of production to the demand point. So up to this point, you should have been able to model a transportation problem. Remember, you need to have supply points, and then you need to specify how much each point can supply. And then you need to have demand points and also specify what is the demand for each point. You also need to be able to balance the problem if it's not already balanced. And then last but not least, you need to be able to determine what is the cost from sending one item from one supply point to one demand point. In the next video, we're going to start talking about how we can find the optimal solution for this transportation problem. So see you on the next one. Thank you.